This is the module 3.3 RSG. So I'm going to go over the examples that are on the formative. The first section of problems asks you to find the point of intersection for two lines looking at the table. And what that means is which point is the same point in both tables. So in order to do that, we have to fill in the table and then look at both tables and find out where do they have the same matching point. So if you'll remember, these are all x values. So I'm going to plug that value in my equation for x. And I'm going to do, for the second table, I'm going to plug those x values in. So this one is when x is 0, you'd say 3 times 0 is 0, minus 5 is negative 5. Right? And then I'm going to plug in 1. I'm going to say 3 times 1 is 3, minus 5 is negative 2. And then I'm going to plug in 2. 3 times 2 is 6, minus 5 is 1. Then I'm going to plug in 3. 3 times 3 is 9, minus 5 is 4. And then I'm going to plug in 4. 3 times 4 is 12, minus 5 is 7. So another way to check to make sure that this makes sense is to look. In my equation, this says the y-intercept is negative 5, so the point 0, negative 5. And it also says that it's going to add by 3, so each time I'm adding by 3. Okay? So we've got our table. For f, the f function filled out. Now we need to fill out the g function table by doing the same process. So start by plugging in 0. 0 plus 1 is 1. Then you're going to plug in 1. 1 plus 1 is 2. Then you're going to plug in 2. 2 plus 1 is 3. Then you're going to plug in 4. 4 plus 1, 3 plus 1 is 4. And then you're going to plug in 4. 4 plus 1 is 5. And again, we can check this is the plane number not attached to x, so that's my y-intercept, starting at 1. And then my slope is just plain x, which is really 1x, so that means my table is going to be adding by 1 each time. So now I have both tables completed, and I just have to look where in both tables do they have the same point. So 0, negative 5, and 0, 1, not the same. 1, negative 2, 1, 2, not the same. Close, but not the same. 2, 1, 2, 3, 3, 4, 3, 4. So that is my point of intersection because they have the exact same point in both tables. The point 3, 4 is the one point that both tables have in common. Okay. The set in this is a bunch of true or false questions. And then the go is, again, those really good practice of the key features of functions. So you want to find the, I think the directions are asking you to just find the domain using interval notation. So remember, domain is the width of a graph. And you're going to go from the leftmost point to the rightmost point of your graph. And then we're going to also use brackets and parentheses. So looking at this graph, I'm going to crop it. My leftmost point is right here. And it's a closed circle, so that means a bracket. So I go from that point, which is negative 4, right? It crosses the x-axis at negative 4. And then it's a continuous line all the way to 0, right? And that point is a closed bracket, closed dot, so I would do a bracket there also. So my domain goes from negative 4 to 0, right? And then it takes a break, right? Between 0 and 1, there are no values. So we make this symbol, which is like a U. It means take a break. Union, take a break. And then after our break, when do we start having domain again? We start having domain right there, which is a closed circle. So I'm going to use a bracket. And that is the point +1. And then it's continuous all the way until this point, which is +1, +2, +3, bracket, because it's included. And then I take another break, right? There's a space that's not included, so I put that U again. And then this last chunk goes from 4 to 5. So bracket, because it's both closed points, 4 to 5. So this is saying my domain is continuous between -4 and 0, and then it takes a break. And then it starts over again between 1 and 3, and then it takes a break, and then it starts over again between 4 and 5. In each of these points, it is closed circles because I used brackets each time. Sorry. So, and then that's all we have to do, only domain. This one is tricky also because it's got an arrow that's pointing downwards. So a lot of us have it's like instinct to start here and then go that way. But domain is always the leftmost point to the rightmost point, right? We go from, just like you read a book, from left to right. So the weird thing about this graph is that it has an arrow. So that arrow means it's going to continue in that direction forever. So my very first value is actually infinity, because it's not just infinity because I'm not going in a positive direction. When I go left, I'm really going negative. So my leftmost point is -infinity. It means it's going to be in that direction forever. And anytime we use infinity in an interval notation, it's always going to be a parenthesis because -infinity isn't actually a number. I can't find that number on a graph. So it's just a concept of that it keeps going forever. So we always use parentheses with infinity. So the leftmost point is -infinity, and infinity always has parentheses. And then the rightmost point stops right here at 1, 2, 3. So 3 is the rightmost point, but at that point, if you can see, they have an open circle, which means it goes all the way up to 3, super, super close, 2.9999999, but not actually 3. So I'm going to use a parenthesis for this also because this was an open circle, meaning it was a boundary, but not actually included. You can get really close to 3, but not actually touch 3. So those are 2 examples of how to write the domain in interval notation. And I hope it helps you finish the